All right. So we've got another way of writing the equation of a quadratic here. This is called standard form. You can see it written right here. And it's still the equation of a parabola. However, it's written in a different way. Okay, and you could actually use some algebra to convert between something written like this and this version here. But I don't know how important that's going to be for you. Don't stress too much about it. Okay, so filling in this table for quadratic relation, the first difference is and the second difference is follow a pattern. In the quadratic relation, y equals 3x squared plus 2x plus 3. For each value of x given, calculate y and the first and second differences. So once again, this is a table of values. We're going to have to use a calculator to fill in the values, just to make sure we're doing this with integrity. I'm not going to give you the answers for exactly this one. I'm going to make up my own quadratic equation, and then I'll show you how to build this same table. I'm just going to use a different equation, so I'll have slightly different results. Okay, so I just need to get a fresh piece of paper set up here. Head over to that page. Okay, so let's say I'm going to use the equation y equals 2x squared minus 3x plus 2. Okay, and then I'm going to build the same kind of table that you saw. So we've got x values -2, -1, 0, 1, 2. And then we have to figure out the y values. Oh, sorry. Using the equation. Okay, so if I'm using this equation, I'm going to do 2. Okay, so the order of operations on this is maybe a little bit tricky. This should be the same kind of calculator that you have on your phone, so you can, if that's the calculator you're using, pretty straightforward. So let's see. So I have to follow BEDMAS, so I'm going to do the squared part first. So I've got -2. So 2, make it negative, squared. And then there's a 2 up front, so times 2 equals. And then I've got minus 3 times 2, make it negative. Okay, so that's on the right track, because I can see, because it's -3 times -2, I know that I'm going to end up adding, so my number should get bigger like it did. And then plus 2 more brings me up to 16. Let me just double check that makes sense. 2 times 4 is 8, minus -6 is 14, plus 2 is 16. Okay, so my first value in my table, 16. Okay, and then I would do the same thing for -1. Obviously use a calculator, or even maybe put it in Desmos and get the values that way. I'm going to do them in my head because I'm a math teacher, so I can. So here I've got -1 squared, which is 1, times 2 is 2, plus 3 is 5, plus 2 is 7. So my next value is going to be 7. This next one's a little bit easier because I can put 0 in, so 0 and 0 plus 2 is 2. Okay, and then 1, so 1 squared is 1, times 2 is 2, minus 3 times 1 means -3, so I'm at -1 plus 2 is 1. And then 2 squared is 4, times 2 is 8, minus 6 is going to be 2, plus 2 is 4. Okay. Hopefully I got those right. Okay, so then the next thing I'm supposed to fill in is my first differences. Okay, and these are differences in y values. Okay, so difference means you take the number below and you subtract the number above. So 7 minus 16 is negative 9. Okay, and then here I'm going to do 2 minus 7, and that's going to give me negative 5. And then I'm going to do 1 minus 2, that's going to give me negative 1. I don't know why I wrote 4, negative 1. And then I'm going to do 4 minus 1, which is going to give me 3. Okay, so that's my first differences. And then I have to do my second differences, which is just repeating the same thing. My second differences will be the difference in the first differences. Okay, so here, negative 9 minus negative 5 is the same as negative 9 plus 5, which is negative 4. And then I've got negative 1 minus negative 5. Negative 1 plus 5 is 4. 3 minus negative 1 equals, oh, that's why. 5 minus negative 9 is going to give me plus 4, plus 4, plus 4. Sorry, I made a mistake there. I forgot my rule about always doing the lower number minus the higher number, or the number below minus the number above. Okay? And this, if you're dealing with a quadratic relation, which is what this is, I can tell because there's an x squared here, then your second differences should all be the same. Okay? So if you're getting that the second differences are all the same, you are on the right track. Okay, so once again, the equation I used here is a little bit different than the one you were assigned on your page. So you will have different numbers than I did when you fill in your y values, your first and second differences, but you will see the same sort of patterns where the second differences will end up all being the same number. Okay, the other thing you might notice, okay, when you look at these values, and it's the same in mine, is that there's a pattern here. I'm going up by 4 each time if I'm looking at the first differences. Okay? A way to answer this question concisely and using fancy mathematical language is that the first differences form a linear relation, meaning they go up by the same amount each time, or you could say they have a constant rate of change. Okay, and then the second differences are all the same. All right, moving on. So you got this nice big, we got this nice big table here. So it looks like you've got the vertex part figured out. So you can pull the numbers out of the equation. The only thing I notice here is that you have to flip the sign on the number with the x coordinate. So because it's plus 4 here, it would actually end up being negative 4 right here. Okay, whereas this one is correct because it's minus 4 in here. It's plus 4 when you actually write the coordinates of the vertex. Okay, so you just want to make sure that you're checking that. So the values, so the x coordinate of the vertex comes from the number inside the brackets, and we always flip the sign on it. So this should be negative 4. And the y value of the vertex always comes from the last number at the end here. Okay, so 6 is correct, minus 1 is correct. This though, plus minus 6 here, that's not right, because if I look at my equation, it's a 7 in here, so it should be minus 7. Okay, that one's good, that one's good. This one, again, there's an error here. It's not minus 4, so double check that. I think maybe when you have a number out front, sometimes that's tripping you up. And then this one, I'm sure you can read it out, okay? Just following the pattern. So the number inside the brackets gives you the x coordinate. So for example, this one should be minus 2 because I have a plus 2 right here. And then the number at the end gives you the y coordinate. Direction of opening. So if there's no negative written out front, then it opens up, which is the example that was given here. And if there is a negative out front, it opens down. So it looks like you've got that figured out. Down, up, up, down, up, down, So this one, that's a positive number out front. So it's going to be up. Okay. Value of A. So A is the number in front of the brackets. Now, like a lot of things in math, if there's no number written there, then the value is 1, okay? Because multiplying by 1 keeps everything the same. Okay, so if there's no number written there, it's not that I write 0, it's that I write 1, like is given in the example. Now this one, it's not just 1 that I would write, it's -1, okay, because there's a minus out front. So my value of A is -1. And then I think that's pretty straightforward. Once you see it, you should be able to fill them in. Okay, fill in those values. The last thing is the step pattern. So this one, I will do an example for you on my paper. So the step pattern, the way that works. Okay, so you have that first line there where you have your A value and then you have your step pattern. So when the A value was +1, the steps were 1, 3, 5. Okay, and that's sort of the basic shape of a parabola. Okay, if the A value changes, then we multiply all the steps by that same number. So if the A value happened to be -2, then my steps would become -2, -6, and -10. Okay? If my A value were 3, then I just take the steps for the basic parabola and I multiply them by the A value. So 1 times 3 would give me 3, 3 times 3 would give me 9, 3 times 5 would give me 15. So then my steps would be 3, 9, 15. Okay? So you can use the A value along with this basic set of steps to figure out the steps for any other parabola. Okay, these last 2 rows, a little bit tricky. They ask you to work backwards. So I'm going to make up a row of the table that looks like this. So we want to know the equation, and we're given a vertex, a direction of opening, an A value, let's say minus -1, and a step pattern, -1, -3, -5. Okay, so here, I can use this information to figure out what the equation would have to be. So my equation has sort of this basic form. I've got an A value out front. I've got X, and then I've got some number that represents the X coordinate of the vertex, and then I've got the Y coordinate of the vertex on the end. Okay, so here my A value, because that's the first thing here, is -1, which means when I write it in the equation, I don't need to include the 1 part, I just make it negative out front. Okay, and then looking at my vertex, the X coordinate of the vertex is 2. Okay, and because it's +2, remember I'm always flipping the sign, so I have to flip to -2 in here. And then my Y coordinate of my vertex is 4, so that is the number I put on the end. Okay, so hopefully you can use that same idea to fill in your own rows of the table there. Okay. And then the last thing it asks you to do is graph. So let me show you what a graph of that function I was just talking about would look like. Okay, so you have your axes. This is a little bit tricky because different parabolas are going to require different axes, but let's just say that I've got 5, 5, -5, -5. So I would plot my vertex at 2, 4, 2, 4. I'm opening down, and my step pattern is -1, so I'm going to go down 1 over 1, -3, down 3 over 1, and then negative 5. Down 5.